Yes. So yeah, hello everyone. I think Lipika has already introduced, but again to introduce myself, I'm Chandrakant, and I have been with Autos for more than 4 years now, and recently got interested into the security things, and have been playing a SecChamp role for our account as well within our project. And so yes, so without further delay, we can just get started with the presentation. Yeah, so here I will be sharing user enumeration. And as I'm saying, this is an underestimated attack because, yeah, so there are many of the applications which are vulnerable to this user enumeration attack that they might not even know, right? Because most of the vulnerability scanners which are present in the current, currently, they all will not be able to tell if the application is, exposed to the user enumeration attack or not. So that is the reason why I'm calling it as underestimated attack. And then, yeah, so let's to get started with, yes, as a part of this presentation, we will be covering our classic questions like what is user enumeration, then you know when where it can happen, and then how it can happen, and then why should we really care about the user enumeration. So yeah, so to talk about the user enumeration, and by the definition, it says it's a common application vulnerability which occurs when attacker can determine if username or emails are valid or not for that specific application. So basically, the aim here is to get the harvest list of all the usernames or emails which are associated with the specific application. So if any attacker or any bad actor is able to validate if specific username or email exists or not for that specific application, then that application is basically vulnerable to the user enumeration. And then, yeah, so why should we really care about this? So one of the blog posts in the intruders, so there one of the posts which I read, which says over 30,000 applications were affected by the user enumeration attack, and there the most popular names were also present. Some of the products from the Microsoft, like Skype and Outlook, were also exposed to the user enumerations. And not to go so far, some of the applications that we develop, they might also be exposed to the user enumeration. And yeah, so where it can happen, so any application which uses username and password for login can be exposed to this. And so most of the application authentications will usually require username and password to be entered for the application, and then uh, wherever the username is present, then user enumeration can be possible. And then, yeah, so as a part of user enumeration, there can be multiple APIs targeted, like sign up, login, and forget password. So if you see, while signing up also, we will need username or email to be present in the request, and similar for login. Login also, we will need username or email to be passed, and then forget password also. And then yes, so so these are all the surface areas where account enumeration can be targeted: sign up, login, and forget password. And then to get into how it can happen, so very easy. As I said, right, any application will require to, if you want to log in, register, or sometimes forget password also will require us to enter username and password. And then if
I want to leave this call.
hello. Yeah, so if we are using any specific error messages for the API, in the responses, then this the data can be exposed. So to show, so let's say this is my login endpoint, and so my screen is visible, I hope, right? Can you see Postman?
No,
Hello.
Chandrakant, it's only the
Okay.
presentation that has been
Yeah,
shared.
maybe I will just share it again. Yeah. Yeah. So can you see the Postman now?
Yes.
Yes. So now, yeah. So here, when I do sign up, let's say I signed up with this email, sign up successful, and then when I try to log in, let's say I enter wrong password, but then yeah, so password does not match. So it says password does not match, and then if email does not exist, it says username does not exist. So this information is enough to tell whether this email is associated with the application or not. So yeah, so this is how logging. So this is how this API is vulnerable to the application just by looking at the message. Uh, Bad actor can say if username is present with that application or not. And yeah, so other ways to achieve this is sorry, I think, yeah. And yeah, so similarly for sign up and forget password, such things can happen. Like while signing up, we know, right, if email does not if email already exists, we will not let user sign up with that email again. And then we sometimes tend to say email does not exist. And similarly for password, if email does not exist within the application and if user is trying to send the forget password link to the email, then we just say email does not exist. So these all messages reveals the information that if that email or username is associated with that application or not. And then another way to get in achieve the user enumeration is timing attack. So yeah, so timing attack I will be showing with the help of this this tool which is known as verb suit. And then so to introduce this is basically a proxy. And then there are other applications also which it can do, like intruder repeater. And basically we can make multiple requests with tweaking the some parameter from the application. So just to walk you through this, so this is the API request that we will be making. And then if you see in payload, there is username and password. And then so this the one which is wrapped between this symbol is basically acts as a variable. And then and to go into the payload, so this is the payload. So all these values will be replaced will be placed here in the position of this text. And then that request will be made multiple times to the same application. Yeah. And then so here we will be hitting login endpoint, post login endpoint with this body. And then this username will be our variable. So to start this attack, we can just see. Okay. Yeah. Yes. Yeah. So this is complete. I just took the 15 emails, and out of which some of the emails are associated with the application, and some of the emails are not. And if you see the response completed time now, yeah, so you can see the clear difference, right? The here for this request, it took just 1 second to complete, and then it just returned back. And then for this request, somehow it went up to 67 milliseconds. And then further, you can clearly see the difference for all the other emails as well. Like for this, it took 1 millisecond. For this, it is 2 milliseconds, and this is a very huge difference, right? Almost around 65 milliseconds difference than the sum of the requests. So if I just sort them, I get to know that this says if you get into the response of it, yeah. So since our application is still vulnerable to that, it says password does not match. So all the password does not match took around close to 70 milliseconds. And then all the other which says username does not exist were exited in 1 milliseconds only. And this happens because the in while logging in, right, we need password. And a password, and so password hashing is very time consuming. Like so the most time consuming part of the login flow is password hashing itself. So and then when username exists, then then only we check if the hash, we try to compare basically hash with the password. And that is where this time difference is coming. And that is how an attacker can differentiate between. So these are all the usernames which are present in the application, and these are all which are not associated with the application. Yeah, and yeah, so earlier I was also talking about this messages, right? Since the message is different, the content length also you can see, right? For this it is 233, and then for this it is through 234. Like while doing this attack, we can by the content length also we can say that these applications are, these are the emails which are associated with the application, and if the content length is 234, we can just ignore it. Yes, so this is how our timing attack will work, and then we'll say if our application is vulnerable to attack or not. And then another way is unique URL. So sometimes we tend to add usernames or user ID sometimes into the URL, and then those sometimes like we feel like to get the correct HTTP status. So if URL or link does not form, we can just return with 404. And if the credentials are not valid, it might seem like 403 is a good idea to keep, right? Because that is not, the credentials are not matching. So basically, but this thing reveals the information, like 403 it says forbidden, and then when we say forbidden, and then for Robin it is coming as 404. It means David exists, but that credentials we do not have, like token is not matching, but Robin does not exist. So if we can just collect all the 403 responses and then say all these usernames are associated with that specific application. Yeah, and then yeah, so since now, yes, so what hacker can do with this data, right? So let's say hacker got the information like all the usernames or emails associated with that specific application. Now that hacker has that data, now what hacker can do with that data? So yeah, so basically, yes, the common goal to get all the credentials. Like if I have the username, I will try to get the password, and for that I can just do the brute force attack. So I will try. So here, since username is already usernames are already exposed, now the chance of getting brute force attack successful increases a lot. Like exponentially it changes. Like if both are unknown, then it is very difficult to guess. If we know that only password is unknown, then it becomes little easier for hacker to do the brute force attack. And then again, yeah, so spamming if your usernames are emails, and then if those list of emails are with hacker, they can just try to spam the spam the user. So to show, right, is what kind of spams we can get. Yeah, so so I'm just using this temporary email box so that I do not expose my own email box basically. So that is why I'm just using this crypto Gmail. And then if I post it, yeah. So yes, so spamming might not look that much of a risk sometimes. Oh, something went wrong. Sorry. Yeah. Okay. I'm sure. Okay, so maybe I'll just share. I think I had something might have gone wrong. Maybe credentials got expired from the trial version. Yes, so I will share. I will just pause my share for some time and. Yeah, so such spams, I just opened my own box in which I sent the mails earlier. And yeah, so such emails can also, you might have already seen some of the spam emails, right? Which talks about, rumors, or sometimes, wants you to click on the link so that their intent will be completed basically. And then such emails they might even cause the reputation to be degraded of that specific application also, right? And then some users might not even like spams, and they just sign off from that application. They just delete their account from that application. So that is some business, there is some business loss also from which comes from the spam. Yeah. And then another thing, yeah, I think this is coming now. Okay. Yes. So yeah. So this, that was another mail. That was my older email. And then so yeah. So this is the spam email where it just says about you've just won some pound of lottery, and then if you click this link with the process, and then there will be some activities happening which are not intended for the user. And then that it's spamming. And then similarly we can do the phishing. So phishing, for those who don't know, so basically it is, you know some of the applications try to be legitimate and then try to act as legitimate application and get the credentials from the user. So such so one of the examples I can share, uh, yeah, refresh. Yes. Yeah, this is one of the examples of phishing. So here, this application, this mail is trying to be legitimate and saying this is coming from your bank. Basically, any bank name can be replaced, and they are asking us to reset our password. And if we enter anything like, let's say, our old password, new password, and confirm new password, and reset the password, it will say reset successful. But behind the flag, that you know information is transferred to the unintended server, and then your passwords are also now exposed. This becomes very easy because user knows which all the emails are already associated with that bank. And so basically target space becomes smaller compared to the brute forcing email and sending it to every email. They can now just send to the emails which are interested in that specific application. So yeah, these are all the ways what hackers can do, and then get hold on the credentials. And then yeah, once they have the hold on the credentials, they can perform any action being that user. And yes, so after all this saying, how we can avoid that, and then what are all the ways we can try uh, to get rid of this vulnerability. So yeah, so first thing, generic messages in API response. So yeah, so if we are just able to send the generic messages uh, instead of sending a very specific messages, then that is the very good start to get rid of this vulnerability. Sorry. Yeah. Yes. And yeah, to go show that, yeah, so now this is the same application, just that some of the implementations have changed. And now for any of the failure, like let's say password is failing, it is saying invalid credentials. And then if username is correct and then password is again wrong, then the message is generic. So by looking at this message, hacker cannot know what is happening behind the flag. And then another way is matching the response time. So yeah, in the timing attack we see, right, the timing differences was bigger. Now if I run this attack again, so now the application is not vulnerable to the user enumeration, And now if we run this thing and add this column of timing, yeah. So now earlier you have seen, right? There was a very huge time difference of some 65 milliseconds. Now the timings are almost similar, like 70 to 75 milliseconds I can see on an average, right? Now, by looking at these timings, no one can say, if some email is associated with the application or not. And even I said, right, I have updated the messages also. Like just by looking at the content length also, there is no change in content length because the message is coming same, even if the username exists or even if the username does not exist. So content length is also similar now. And yeah, yeah. So one more, yeah. So sign up. So sign up in the sign up flow. Most of us we know, right? When users signs up, and then if they try to sign up with an existing user, make sure we send the password reset email to the user, which is who is trying to re sign up using the same email ID. So that way, user will get to know if that action was intended or someone else is trying to sign up using the account, using the email of that user. And then in reset password, send the reset link if account exists, and then send the sign up link if account does not exist. So in reset password, we know we usually send the link to the user, and on click of that, we get them to the different reset password page, and from there that process continues. And then similarly, that email sending we need to do for both if user exists and if user does not exist. And if user does not exist, we will just send the sign up link to that user. And then captcha, yeah. So captchas are very useful in that scenarios. Like even if in user enumeration, here in captcha, just username and password is not enough. So along with the username and password, they will need to verify the captcha also to proceed with the flow. So that way, those APIs become secure. So the goal is to make the APIs as secure as possible, and then captcha are very useful in those scenarios. And then exponential backoff. So so most of the applications will have this, right? So if user makes multiple attempts of with the wrong credentials, then we will add some backoffs. Like so for the first time, if user tries for 3 times, and then we say please try to log in after 1 hour, and then even after that the 3 tries are over, and then we can just say please log in after day or week or sometimes some months also. And so that will help us to safeguard us from the multiple attacks, like repeated attacks coming onto the application. And then brute force and such things will not be possible. Yeah, so to recall, when we when we are implementing the application and we want us to be secure from the user enumeration, we need to take care of the messages, like what error messages we show to the user when credentials are bad or something like that. And then time, what is the response time, like if username is exist, how much time it takes, and then if username does not exist, how much time it takes. We need to be considerate about that. Limiters, so as I said, that exponential backoff, and then how many requests can user make, the IP rate limiters, all of this will help us to avoid the brute force attack side of it. And then captchas, so captchas are always captchas are very useful when it comes to like sending credentials. This is an extra validation which user needs to do every request, and that captcha makes sure that it is coming from the valid user, and brute forcing is not possible with that application. So yeah, so that is I think all from us, and these are all the references that I use. So Hex Planning, I think this is my go-to place for any vulnerability check, and then any vulnerability if I want to know more about, I just go to the Hex Planning. And then Portswigger so this is where the burp tool I was using. So if you want to know more about that, maybe you can just visit that site. And then Intruders Post. So here some of the security related blogs will be published, and then we can just go and look at this advice. Yes, so thank you. I guess, yeah, so this is all I had. I think we are too early for the time, but yes, any questions, anything, any suggestions, we are open.
So I have a question. Can brute force attack be eliminated with this exponential backoff, or is it still possible?
Yes, we can avoid brute force attack with the exponential backoff, right? Because basically this exponential backoff will act as a rate limiter kind of a, right? So for a certain amount of time, you can only make specific number of bad requests to the application. Like let's say for 1 hour, only 3 bad requests can come, and after that, all those will be saying, rate limiter will say basically you cannot make this request, and then it will be stopped before reaching the application. Yeah, so brute force will not be possible, right? Because now user only can try after 1 hour now, and after that some days, some weeks, and sometimes some months also.
Okay. Thank you.
Yeah. I have one question. How did you achieve the similar response type for multiple invalid credentials?
Yeah.
Did you add delays?
No, yeah. So delays is one of the options, definitely. And then yes. So for now, what I did, so we know that password comparison and then password hashing are usually the time-consuming processes. So there are multiple ways we can avoid this. So what I did is currently basically even if credentials are wrong, I am performing the actions which I will do when credentials are correct, right? So password is just like hash comparison, right? Instead of doing hash comparison only when username exists, I am doing hash comparison even when username does not exist within the application. So that matched up the time. So, and yes, as you suggested, even many people use delays also to match the response time. Yeah, that is a possible way as well.
Yeah, because that way you might even reduce some database calls if you are using database somewhere for this checking.
Yeah. So I will tell you the problem. So problem with delay. So delays, right? Okay. So application, so hashing, right? Hashing time will change on the environment basis also. Like if I'm doing it locally versus the server is doing it, there will be some difference. Like let's say on local hashing takes around 60 milliseconds, and then on the server it takes around 200 milliseconds, and that keeps varying, right? So now I cannot come up with the specific number with which I can add that delay, right? So that is where I feel like if we perform those actions, the timing will be same. Like no matter which environment we use, the timing difference will make it similar always.
Hello.
Deepika, right? You get it?
Yeah, got it.
Yeah, so
thank you.
So that constant number we cannot come up with. That is why delays are sometimes not, it's like that people do use delay, but that is sometimes not visible, like sometimes only.
Okay, next. I think someone else was also saying something.
Yeah.
I had a question, Chandrakant. What do you think is more secure? Is having a long password is more secure, or having a smaller password with lots of different characters? Like, which would be more secure to prevent brute force attack?
Okay. Yeah. So yes. So long passwords are like as basically, right, I'm not that expert, to talk about the passwords and everything. What I feel is, the longer the password, the longer time it will take for us to do the brute force, right? So let's say if you have the length of 4 only and characters, so achieving the brute force there will get easier, because only the combinations present there will get reduced exponentially. Like even if you add one character, that combination adds on very big complexity into the password, right? So longer password with with different characters is something which I will prefer. Like combination of both. Yes. Yes, Lipika, I think we closed it way before the time.
Yes. But nice, Chandrakant. Any other questions we have? We can utilize this time for any kind of discussions or clarification if we need.
Yeah.
All right. Oh, sorry. There was
just one thing. So can you share those links that were there in the last slide?
Yes.
These ones.
I will do it right now. Yeah, in Zoom chat.
Okay, so Chandra, I think okay, I will stop the recording and then we will take this question. Thank you all. Yes, I will stop this recording.